We are so excited to have with us today Dr. Marcia McNutt, the president of the National Academy of Sciences. She is a geophysicist and has previously served as the director of the U.S. Geological Survey and as the president and chief executive officer of the Monterey Bay Aquarium Research Institute in California. Dr. McNutt, thank you so much for joining us. We at Young Women in Bio would love to learn more about your educational background and career path that brought you to where you are today.
Well, thank you, Sarah, for inviting me to come speak to you today. So very happy to be here. So I can start out by saying that I grew up in the Midwest in Minnesota, and I grew up in a family in which there never had been a scientist. So it was interesting because after I started my career in science, I realized that most of my colleagues had grown up with either a father or a mother or an aunt or an uncle or someone in their family who had been either a doctor or a scientist or an engineer and had encouraged them to choose a career in a STEM discipline. But that wasn't the case for me. And so, I don't know, I can't tell you to this day how it was that I decided I was going to be a scientist. But I can tell you from the time that I was very, very young, I always envisioned myself as a scientist. I never thought I would be doing anything else but science. And I always thought that I'd be doing science outside. I never pictured myself in a little white lab coat with beakers in my hand, titrating solutions. I always was outside exploring.
That's wonderful. And can you tell us a bit about your educational background once you moved into college and what you first did out of college?
Sure. So my education background was sort of interesting in that from the time I was in second grade onward, I went to an all-girls school. And I had only sisters in my family. So all of my influence was female dominated. And therefore, later, much later in life, when I first encountered this notion that, oh, girls aren't good at math or girls can't excel in science, that wasn't until I was in college. And by that time, it was too late for me to be influenced by any of that kind of thinking, because anyone in my life who had been doing well in math or science had been female. And so I knew that that had to be wrong. And it was interesting because years later, when I was at the National Science Foundation as part of a cohort of women who had received some prestigious fellowships to fund their sabbaticals, to go to other departments and show departments that had no women on their faculty that it really wasn't all that scary to have a woman on the faculty. It was instructive to see how many of the senior women in STEM fields that were part of this program had also come from single-sex education backgrounds. So being part of an all-girls school, as I said, I just never encountered any resistance to the idea that I could be a scientist. So when I went off to college, I was intent on majoring in physics. And it wasn't until I got to college that I was told by one of my physics professors that many girls had come and gone, but there was yet to be one to major in physics. And he was sure that that would not happen. And that just made me all the more determined to prove him wrong. So I did. I graduated in 3 years, summa cum laude, with my major in physics. and then went on to graduate school at Scripps Institution of Oceanography in the field of geophysics, which was, of course, a very, very hot field to be in at that time because it was at the dawn of the revolution in plate tectonics.
Mm-hmm. That's incredible. Absolutely amazing. Congratulations on all of that success you've had up until that point and through now. So we know you've spent time at the Monterey Aquarium and at the National Academy of Sciences. Perhaps you can tell us a bit about what it is that you've done at the aquarium and now what you're doing at the NAS.
Right. So the earlier part of my career, I was on the faculty at MIT, and I spent 15 years teaching and mentoring students and doing research, going on oceanographic expeditions all over the world from MIT. I absolutely loved that job. I really never thought that I would do anything else but be a faculty member at MIT. And then one day I got a phone call from someone who was on the board of directors at the Monterey Bay Aquarium Research Institute in California. And they asked if I would be willing to come interview to be the director of MBARI, as it's called. And I thought to myself, whoa, why would they want me for this job? I've never run anything larger than my own research group. And here they want me to come talk to them about running an entire research institute, an oceanographic lab that has ships and machine shops and labs, chemistry labs, biology labs, physical oceanography, all sorts of complexities. But once I got out there, I could sort of see the method to their madness in deciding to talk to me. The Institute was unusual among other research institutes in that it was entirely funded by the Packard Foundation to do high-risk research that the federal agencies generally steer clear of because of the fact that failure is an option. And for that reason, the previous directors, the Institute was only 10 years old at that time, and previous directors had had a difficult time encouraging the high-risk nature of the organization. And instead, they had come from normal academic departments and were encouraging the kind of science that could easily be done on funding from NSF or the Navy or other institutions. And so they felt it would be good to get someone in who didn't have a preconceived notion of how the place should run, but could run it instead like a high-risk incubator. So that's what I did there. And during those years, I was there for 12 years, the Monterey Bay Aquarium Research Institute did amazing work. The kind of developments that people thought were impossible. We fielded the first device in the ocean that could determine what microorganisms were blooming in the ocean based on their RNA by just doing an in situ sample process and a sandwich hybridization that determined what was blooming based on its genetic code. And we put the first device in the ocean in the deep sea that could determine the chemical composition of material in the ocean by pointing a laser at it and doing laser Raman spectroscopy in the deep sea. We fielded the first deep sea ocean observatory to study the chemistry of CO2 in the deep ocean, as might happen in response to ocean acidification, and all sorts of other amazing things. We ported artificial intelligence to underwater vehicles so that they could do their, you could just give them a high level mission and they would determine how to do it based on using input from their own sensors to complete their missions. So it was an amazing time there. And then after I left MBARI, I was invited to, by President Obama, to become the director of the US Geological Survey, which was a huge step upward from an institution of several hundred to an agency of 7,000 to 8,000 workers. But it was a time when I learned just how important the federal service is to the nation. The USGS provides the basic science that provides us with clean water, with critical minerals, with energy supplies. It does the science behind siting solar energy and wind energy. It provides the mapping services, and it determines the science behind invasive and endangered species. It keeps us safe from earthquakes and volcanic eruptions. It was a great time to be director of the USGS, and I loved it. And then after that, I became editor-in-chief of Science magazine. And as editor-in-chief, I expanded the offerings of journals in the science family, including moving to open access with Science Advances. And I loved that job, but then got offered the opportunity to be president of the National Academy, which has been a fascinating experience. The Academy serves as the Supreme Court for science. It's where the scientific consensus is determined, and it's where we advise the nation on what the science says and what the science doesn't say. And as you can imagine, it's been an interesting time to be a scientist trying to advise the federal government.
I can imagine, especially with everything that's going on. Has the COVID-19 pandemic changed the way in which you work on a day-to-day basis this year? And if so, I'm assuming it has. What has been the biggest impact?
Well, it's been interesting because the Academy has always done its work by convening expert groups of scientists from all over the country, from the top institutions, the big names, pull them together either in Washington or in our center in California and get their agreement on what the science says on certain topics. We've, of course, moved to virtual convenings, as everyone has. And what we've found, actually, which has been important, is that it's been easier to get people together. Scheduling problems have mostly evaporated, but that's mostly because people are home and no one's traveling anywhere. We found that we can be much more inclusive. It's, people that maybe couldn't travel because they have young children at home or they have physical limitations that prevent them from traveling. They can join us through virtual convenings. We can get our work done much faster. So all of our experts love it. Our staff loves it. And all of the stakeholders who need this advice love it because we're getting the advice to them faster and at lower cost. So it's been a good experience.
Yeah, it seems to be one of the silver linings is really expanding our reach and being able to draw in more people and get more people involved in the things that we're doing, which is wonderful to hear. So you mentioned that throughout your career and your education, you've had a lot of very strong women supporting you along the way. And something that we do try to promote within YWIB is encouraging young women to seek out mentors and network as much as possible. Could you give us some advice as to how you would recommend approaching a mentor if you're looking to find somebody new, and maybe some of the things that you've gained over the years, both as a mentor and as a mentee?
Yes. Well, So when I was in college and graduate school, all of my mentors were male, and they were fabulous. So I don't want to give the impression that all of my mentors were female. Certainly when I was in high school and junior high, that was the case. But that wasn't true when I got to college and graduate school. And I'll tell you, as an undergraduate and as a graduate student, I changed advisors until I found someone that I knew would be a great mentor and a great advisor for me. Someone that I knew I just clicked with and who was going to have my back and who was going to support me. And it's interesting because both my college advisor and my graduate advisor have been exceptional advisors for women, even after I graduated, because they have sent me students that they worked with as postdocs and as undergraduate research assistants that have also been exceptional. And so they continued to mentor women out of proportion to the number of women entering the field. So I think there are some people, some men that just are exceptional mentors of women. But having said that, I have to admit that I have mentored more women than men. And I think the reason for that is that it helps when you're mentoring someone that you have some personal basis to just connect to the person with. And I've had so many great women students that I just love to be with. You know, we just had common interests, whether it was talking about our children or talking about our outside interests or talking about our challenges of being women in science. There was just a lot we had in common. And that's not to say that I didn't have fabulous men that I mentored as well, but there were just more women that I naturally connected with. And many times those women sought me out. And all it took was saying, gosh, I'd really love your advice on something. Marcia, could we have lunch together and let's sit down and talk? And that would be a basis for finding, do we click? Do we get along? Is this going to be a relationship which is worth pursuing, that I can help you and I can be your advocate? And that's all it took.
Thank you so much. It always seems a little scary the first time you reach out to somebody, but like you said, every time I've asked somebody if they would be my mentor, I was always welcomed with open arms. And likewise, whenever a young woman has asked me to mentor them, I've done the same. So this has been so educational. I've learned so much, and I'm sure our listeners have as well. One last thing before we go. What would be your one piece of advice to middle school and high school students as they seek a career in STEM?
I think my one piece of advice is don't ever opt out by taking the easy road. Make sure that when you're in high school or in college, that you purposely seek out challenging courses and opportunities that are available to you along the way. And let me give some examples. Let's suppose your high school has a couple options for a biology class you can take. One is an AP biology class that you could take, and the other is marine biology. Now, I'm an oceanographer, and let's suppose you want to be a marine biologist someday. And so that marine biology class is sounding really attractive. I'd still tell you, take the AP biology class, because the AP biology class is probably going to be much more rigorous than the marine biology class. And it is going to give you a much more solid foundation that you will need to build upon. And you can learn the marine specific aspects later in your career. But if you don't have that solid foundation that you can build upon, then, knowing various, to be able to, distinguish between, a cnidarian and a ctenophore, that's not going to help if you don't have the solid foundation to build upon. So that would be my advice.
That is a wonderful way to end this call. Thank you so much,